You're in the kitchen. You need a spoon. You walk into the living room to get it. You stand there, spoonless, staring at a couch that has never once held a spoon, blinking at a room that suddenly feels unfamiliar, like you've wandered into someone else's house mid-thought, holding a thought that no longer has anywhere to land. You retrace your steps mentally. Kitchen, drawer, spoon, living room. None of it reconnects. The thought is just gone, replaced by a low, quiet confusion about what you were even doing standing there in the first place. You even pat your pockets, as if the reason might be sitting in there along with your phone. Your brain didn't lose the information. It deleted it on purpose, the second you cross the doorway. This video is about why walking through a doorway erases your short-term memory, and what that says about how your brain decides what's worth keeping and what gets thrown out without asking you first. By the end of this, you'll understand why your memory isn't broken. It's running a filing system so aggressive it treats rooms as folders and closes them the moment you leave. And once you see it, you'll start noticing it happening. In places that aren't rooms at all. Places you'd never have thought to call a doorway until now. Psychologist Gabriel Radvansky at the University of Notre Dame ran the first major study on this in 2011. Participants walked through a doorway carrying an object, then had to recall details about it. Size, color, what it was for. Recall dropped every single time they crossed a threshold, no matter how simple the object or how short the walk. Meanwhile, when people walked the exact same distance but stayed inside a single room, memory barely dipped at all. Radvansky ran this study multiple times, changing variables to rule out other explanations. Maybe it was the extra steps. Maybe it was distraction from navigating a new space. Neither held up. Even when participants walked in a large circle within one room, covering more distance than the doorway group, their memory stayed intact. It really was the boundary itself doing the damage, not the walking, not the time, not the effort involved in getting from one point to another. The doorway itself was the trigger, not the walking, not the time elapsed, the boundary. But here's where it gets interesting. Radvansky's team didn't stop at real rooms. They ran the same test in virtual reality. People wearing headsets walking through digital doorways that didn't physically exist, in spaces that didn't physically exist. Same result, almost identical drop in recall. Memory failed just from believing they'd crossed a threshold. Your brain doesn't care if the doorway is real, made of drywall, or made of pixels. It just cares that you told it, "I've left." That belief alone is enough to trigger the reset, which is a strange amount of power to hand over to a hinge and a door frame. This is called an event boundary. Your brain constantly organizes experience into discrete episodes, like chapters in a book, and a doorway is one of the clearest, cleanest chapter breaks there is. Cleaner than most transitions you'll experience all day. But here's where it gets interesting. Cognitive scientist Jeffrey Sachs at Washington University studies something called event segmentation theory. His research shows your brain is quietly asking itself a version of the same question dozens, maybe hundreds, of times a day. Is this still the same event, or has something new started? When the answer comes back new, your brain performs a kind of soft reset, clearing out working memory to make room for whatever's coming next, the same way you'd close one document before opening another. Sachs argues this isn't a glitch in an otherwise smooth system. It's the system working correctly. Without event segmentation, your mind would treat an entire day as one undifferentiated blur. No sense of that happened earlier versus this is happening now. The boundaries are what let you experience time as a sequence of distinct moments instead of a single unbroken smear. In a strange way, forgetting the spoon is the cost of being able to remember your day as a story instead of static. Working memory itself is tiny, far tinier than most people assume. Psychologist Nelson Cowan's research puts its real functional capacity at around 4 items held at once. Not the 7 you may have heard growing up, which turns out to be closer to a folk number than a precise one. 4 slots. That's the whole desk you're working with at any given moment. And every one of those slots is expensive real estate. So the moment your brain flags a new event, it doesn't gently update those 4 slots one at a time. It wipes the desk clean and starts over. Spoon-related intentions included no negotiation, no warning, no chance to grab what mattered before the reset hits. But here's where it gets interesting. This isn't only about physical rooms either. Decades of research into context-dependent memory, going back to a well-known study where divers memorized word lists both underwater and on land, found something almost identical happens with environment generally. The divers recalled significantly more words when tested in the same environment where they'd learned them. Recall underwater, remembered better underwater. Recall on land, remembered better on land. Your memory isn't just tied to time, it's tied to place. Move the place and the brain quietly assumes the content doesn't automatically travel with you, that it belongs to wherever you learned it, like a coat you forgot you left hanging in another room, which means your kitchen brain and your living room brain are, in a small but very real sense, running separate files, each one slightly walled off from the other, filed under a different address, waiting for you to physically return before they'll hand the information back over. But here's where it gets interesting. There's a physical piece to this too. Neuroscientists have found that the hippocampus, the brain's indexing system for memory, fires distinct patterns of activity at the exact moment someone crosses a boundary, even in tightly controlled lab settings where nothing else about the environment changes. It's not a metaphor. Your brain is generating a literal, measurable marker that says, "New chapter starts here," and that marker is what triggers the clearing of working memory in the first place. This marker doesn't just clear old information. Some researchers believe it also acts as a bookmark, making it easier to later recall what happened before the boundary, precisely because that information got sealed off and filed away as its own distinct unit, rather than blending into everything that came after it. The forgetting in the moment may be the price of better organization later, a trade your brain makes automatically, without ever asking whether you'd have agreed to it. But here's where it gets interesting. This effect scales with how strong the boundary feels. Researchers have found that bigger, more distinct transitions, leaving a building entirely, changing floors, stepping outside, tend to wipe memory more thoroughly than small ones, like moving between 2 similar rooms. The stronger your brain's sense that this is a genuinely new place, the harder it slams the door on whatever you were just holding on to. A short hallway barely registers. A flight of stairs registers a great deal more. Here's the wrinkle. This doesn't just happen with physical doorways anymore, switching from one browser tab to another, opening a new app, even standing up from your desk to answer a text. Each one can function as a miniature event boundary, a digital doorway your brain treats almost exactly like a real one. That's part of why you'll open your phone to check a single notification and, 10 seconds later, have no memory of what you were actually doing on the device you were holding 30 seconds earlier. Some researchers even suspect this effect is becoming more frequent, not less, because a modern day is stitched together from far more boundary crossings than a day 1 or 2 generations ago ever required. More rooms, more tabs, more apps, more resets, more chapter breaks stacked back to back one after another all day long. It's not that your memory has gotten worse. It's that you're asking it to file more folders in a single afternoon than it used to have to manage in a week. There's something almost funny about it, if you squint. A species that evolved this mechanism to track predators, moving between clearings, in a forest is now using the exact same machinery to lose its train of thought between a group chat and a food delivery app, the ancient system. Running on modern doorways, it was never designed to count this fast. You're back in the kitchen. You still need the spoon, except this time you know what actually happened in that doorway. Your brain didn't misplace the thought or fail you. It closed a chapter, right on schedule, exactly the way it's built to. The same mechanism that's been quietly filing your life into rooms since long before you ever noticed it working. Maybe forgetting isn't the failure. Maybe it's just your mind, quietly turning the page.